CODERS from Missouri State University presents Classroom Strategies.
Hi, this is Dave Cornelison for CODERS Council, and today we're going to talk a little bit more about magnetic fields, some very specific cases. Let's recap. Batteries provide a voltage which can push a current through a resistance. We've already talked about this several times. The bulb can be the resistor, and a bulb has quite a bit of resistance because we want the bulb to glow. Remember that. But we can take the bulb out, and instead we can put a long coil of wire. And when you have current going through a long loop of wire, looped over and over and over again, you can get magnetic field. We've already demonstrated there was magnetic field there by manipulating a compass and showing that it moved in response to the field, and by picking up these steel marbles, which were ball 1, whereas the aluminum marbles are not picked up and the plastic ones, of course, are not picked up also. But now we're going to go a little bit deeper. This would be something you would do with students that were a little further along. But to explain what we're going to do here, we're going to go up to the board and draw a few diagrams. So one of the things you got to remember, or you should remember, you need to remember, is that the magnetic loops, so to speak, the coils, we'll call them our electromagnets, they essentially have a resistance. Not very much resistance. Why? We don't want them to glow. We just want them to have quite a bit of current running through them. So what we're going to do is we drew a resistor like this, if you remember. There's our resistor. Our bulb was a resistor. We could have drawn an actual picture of a bulb, but that's kind of difficult. It depends upon your artistic ability. So this was our bulb. Our magnet is going to look like this. It's loops of wire. And so we draw it like that typically. That's also the symbol people use in circuits for something else called a solenoid. So a solenoid and an electromagnet look very similar. Now, one of the things we're going to show later is we're going to show that the material that's in the middle of this coil, which we wrap the loops around, it can be made out of a material. It could be plastic or wood, or it could be a magnetic material. We're going to talk more about that later. But now let's just say we're going to take this, the electromagnetic coil, and we're going to place it into circuits in place of what we originally did, which was a battery and a bulb, which was a bulb. So now what we're going to do is we're going to draw a circuit. Let's draw this and see if we remember what we're doing here. Here's what we did. This was a battery and one bulb. And we knew that when we did that, we got a unit of brightness, which was a stand-in by visual brightness. We call that I, 1 unit of I. We looked at it and we said, how bright is it? And we had 1 unit of I. And we could do something like this also. We could put 2 bulbs like that. And we could put them in series, you remember? And if we did, the first thing many people suggested is you should still have whatever this unit of brightness was, you should still have the same brightness here, but we learned that that wasn't true. We instead had I over 2 going through each of these, where I was this, because the resistance was larger. This was called a series circuit, remember? Series. And then the other possibility looked like this. This is, we go through one bulb and we also go through the other bulb. Let's go backtrack real quick. Remember, this is leave one bulb and go into the other. So if I break any of these connections, this one, or that one, or that one, the entire thing goes dim, goes dark, no brightness. On the other hand, here, if I cut this one out, there's still a loop on the outside one. Conversely, if I cut this one out, there's still a loop on the inside one. So now, this one and this one are in parallel. This is called a parallel circuit. And amazingly enough, I have I here and I here. So actually, through the battery, I would have 2I. This is going to drain your battery much quicker. This would be like, gee, if I ran a house on batteries and I turned on every light in the house, would it drain the batteries faster? And the answer is absolutely yes. Okay, now, what can I do to make my magnets follow these same things? Well, I'm going to use an analogous. I'm just going to take out the resistor, which is the bulb, and I'm just going to draw it like this. There I have going through one of the loops. There I have it going through 2 of the loops. Here I have it going through 2 of the loops, but in a slightly different configuration, like this. Okay, now, these are the different ways that I could hook this up. We're going to go back and we're going to reproduce these. We're going to take first, and we're going to use 2 batteries instead of 1 because I want more oomph. That's all. So what we're going to do is we're going to hook up one. Here's one like this. So remember, we're going, and it's very difficult to see, but you can see that there's a tab on this wire, into the tabbed wire and out of the tabbed wire. That's one. We go like this, we do this, we pick up some little BBs there, you can see that, and we unhook it, and there they go. Now what we're going to do is we're going to go in series. So let's think about this. We go into a tab, then out of the tab, then we have to go into the second loop. So we got to go jump back down here like this because we want to go through the same way. If I'm curling around this way, I want the next loop to curl around that way also. So I'm going to go down here like this and back down to this side like this. Okay? And then I'm going to come out back to Mr. Battery right here. Right here. Okay? So now I get a little bit more. I have two loops going. That's quite interesting, and we're going to talk more about that later, but you can see that you get that. Now what I'm going to do is I'm going to hook them in parallel, because you can see that by unhooking one of them, which I just did, I unhooked the connection between the two like that. That was in series. Then the whole thing went adios. Now what I'm going to do is I'm going to hook it up in parallel. Let's see how we do that, okay? So first of all, watch me. I'm going to hook up both batteries. I'm going to go, this is tab, tab, like that. And then I'm going to hook up both batteries, right? Here's another thing right here. And I'm going to hook up untabbed. Excuse me, just a second here. I'm going to go, yeah. I'm going to go. Got to make sure my plus minus, you should always check your plus minus. Let's check this out. I go plus, minus, plus 2 tab, minus 2 tab, like that. And then I go plus 2 tab, 2, and minus 2 tab, 2. Like that. Now, there you go. You have 3 different ways you can hook these up. Those were in parallel. Now, if I undo this, I'll drop some, but amazingly enough, I won't drop them all. Right? I undid one, but if I undo the other, now I drop them all. See, so by undoing either one or the other, I still have one of the loops going. Now, there's one other way we can hook these up, which we haven't talked about at all. In a wire that is connected to a bulb, it doesn't really matter which way the current flows. If the current flows this way through the resistor that is a bulb, or this way through a resistor that is a bulb, the bulb will light up. It doesn't matter. Magnets are weird. If I have the current flow one way through the magnet, like this, I will get a field of a certain sort. But if I have the current flow the other way, right, which means down the other way, I will get a magnetic field that points in the opposite direction to the first. This is something you could conceivably add at a higher level, perhaps 8th grade or something like that. So what I'm going to do is I'm going to leave it to you to think about a way that you could have the current go into one loop and out, and then instead you'd flip the polarity so that it goes into this loop and out down here at the same time. So now I'd have one going this way and one going the other way. And now the fields will cancel each other out, and the number of BBs you pick up will be many fewer than you would otherwise expect. I want you to look at that yourself. That's a very peculiar thing. It's beyond the scope of something like 3rd, 4th, or 5th graders. But once people start getting into the middle school grades, they can start to think about the magnet can have a field that points one way, or it can have a field that points the other way. Once again, this is Dave Cornelison for Coders Council.